Good morning. With this snowy Friday, I wanted to give everybody a chance to see what we're doing today. We're going to be continuing with our carboxylic acid reactions. And what we're going to do is a quick review of some esterification. We will also go over the definition of buffers. So I'll start with an esterification example, and then I will talk about hydrolysis. This video will probably be uploaded in two parts so that it's easier for you to look at. But our main focus of today is going to be looking at hydrolysis reactions of esters. As far as the quiz goes, if you weren't able to make it to class, I will be emailing out an announcement about this and how you can get credit for the quiz. The homework on Mastering Chemistry is due on Monday night, so continue to work on that and email me if you have questions. On Monday, we're going to be talking about reactions that make amides. And in order to do that, we need to know a little bit more about amines. So please have a look at those sections and how they relate to our current discussion of making esters from carboxylic acids and alcohols. Amides are made from carboxylic acids and amines. Please remember that exam 4 is on December 7th. That's on a Friday. The updated schedule was sent out via an announcement yesterday. I know there was, or on Wednesday, I know that there was a little bit of confusion about when that link became active, and I apologize for that. But it is now in the syllabus folder on Blackboard, and you can access it through the announcement that is also on Blackboard on the front page. Just a quick reminder about buffers. Things that I really want you to remember about buffers is that a buffer is a combination of a weak acid with its conjugate base. Because it's a weak acid, its conjugate base should also be a weak base. This is what makes it a buffer. It has to be this combination. And the biggest thing is that a buffer resists changes in pH. So the weak acid can buffer an addition of a strong base, and the weak base can buffer the addition of an acid, and only minimal changes will occur to the pH. We finished up on Monday talking about esterification, and this is a carbonyl group substitution. We saw substitution at the carbonyl group, or addition at the carbonyl group when we made hemiacetals and acetals, and now we're doing a reaction that you did in lab where we react a carboxylic acid with an alcohol to give us an ester. And I'm going to draw an example of that just as a reminder. This is not shown in here, but this does need to have an acid catalyst, and we also produce a molecule of water. So let's have a look at an example of making a carboxylic acid. Making an ester. So the carboxylic acid that we're going to start with for this ester that we're going to make is going to be propanoic acid. This means we're going to have 3 carbons. So 1, 2, 3 carbons, or we should number this. I'm going to put the carboxylic acid here, so this is carbon number 1, carbon number 2, carbon number 3. So then to make the carboxylic acid, I put my double bonded O and the OH. So now we have the carboxylic acid functionality. This is carbon number 1, carbon number 2, and carbon number 3. We are going to react this with isopropyl alcohol. So isopropyl alcohol, remember, is the alcohol functional group, and it's going to be connected to 3 carbons in the middle. So carbon 1, carbon 2, carbon 3. So this is isopropyl alcohol. Or it could also be called 2-propanol. Or it could also be called isopropanol. Okay. To do this reaction, we need to add an acid catalyst, and so we'll do it that way. When we do the esterification reaction, what's going to happen is that this H that is a part of the carboxylic acid is going to combine with the OH of the alcohol, and we're going to get water. So this H combines with the OH and we get water, and then this bond that was to the alcohol OH is going to now connect to that O. And so we simply make the new connection. And I'm going to have to draw it down below because I didn't leave enough room. So we draw our carbonyl. Sorry, that's a bad double bond. Bonded to an O. And now we bond it to the isopropyl group. And now we've made our ester linkage, which is a C double bonded to an O, single bonded to an O carbon chain. And what we do is we take the branch that was the alcohol and we name it as a branch. So we would call this isopropyl. So isopropyl, and then the propanoic acid part becomes, the ic becomes an 8, and we call this isopropyl propanoate. So this ester is isopropyl propanoate. So this is an example of an esterification reaction. Just to go over a little bit of reminder about how we name esters, right? If we look at an ester where we have this ester linkage, carbon double bonded to an oxygen, single bonded to an oxygen, all right? That's our ester linkage. The new bond that came from an alcohol, or the new part that came from an alcohol, we name as ethyl. Here in this case, we have a 2-carbon unit that came from acetic acid or ethanoic acid. So, as I mentioned in my example, the ethyl alcohol portion becomes the branch name, so that becomes ethyl, and the acetic changes to 8, so it's ethyl acetate. This would be called benzoic acid. This is from methanol or methyl alcohol, so we call this methyl benzoate. So benzoic becomes benzoate. So it's simply called methyl benzoate. I'm going to stop this portion, which is a review of esterification, and then the next portion, which will be a separate video, will be the hydrolysis of esters and some different ways that esters can be taken apart.